All right, those are the distance, speed, time problems. Let's take a look at work problems or sharing a task. Emily takes 4 hours to paint a room. It takes Selena 3 hours to paint the same room. How long will it take if they work together? So, first we're going to state the amount of time taken to paint the room individually. For Emily, it takes her 4 hours. For Selena, it takes her 3 hours. The fraction of the work that is done in 1 hour, well, if it takes Emily 4 hours to complete the entire job, every hour she's completing 1/4 of it. For Selena, every single hour she's completing 1/3 of it. If I'm going to figure out how much work is done in T hours, I would just multiply the speed times the time, which is T. Now, just like in our previous speed problems, the speed of something plus the speed of something else will create their combined speed. Or, in this case, if I'm taking the fraction of the work done in T hours, then T is the amount of time that it's going to take for them to work together. So I'm going to say that 1/4 times T, which I can just write as T/4, plus T/3 is going to equal the amount of time it takes for them to complete one job. Because they're just completing the same job together. So their distance is just going to be the one job. So the distance of her plus the distance of her is going to create the total distance of one job. Then, because I have a common denominator of 12, I'm going to say that I have 12T/4 plus 12T/3 is going to equal 12 times 1, or 3T plus 4T will equal 12. If 7T equals 12, then T is going to equal 12/7. And 12 divided by 7 is going to be approximately 1.7 hours to complete it together. If I want to use the distance, speed, time formula to solve how this is going to work, well, my time is going to equal the distance is 1 for them to do everything because it's just one job, and then the speed that they're working at together is going to be one person's speed plus the other person's speed, which I can say is the same as 1 divided by 1/4 plus 1/3, or when I put it over a common denominator, 1 divided by 3 plus 4/12, 1 divided by 7/12 is the same as 1 times the reciprocal, 12/7, which is still going to give me that same answer of 12/7. And it gives me the same solution either way. For example 7, I'm doing the same process. Mark can weed the garden, working alone in 90 minutes. There's his time. Shelby can weed the garden, working alone in 75 minutes. There's her time. If they work together, how long will it take them to weed the garden? I'm going to say that in this case, let X be the required time. Working together. So in this case, I'm going to state that if he gets 1/90th of it in terms of minutes done every single time, then it's going to be 190 times the total time, or X over 90. Plus, if she takes 75 minutes by herself, X over 75 is equal to 1 because they're completing the one job together. The common denominator here is going to be 90 times 75, which means that I'm going to say that if I have 90 times 75 times X over 90 plus 90 times 75 times X over 75, it's going to equal 1 times 90 times 75. $75x plus 90x is going to equal 6,750. If 165x is equal to 6,750, then x is going to equal 6,750 over 165, which can get reduced down to 450 over 11, which is going to be approximately, because it doesn't divide it exactly, 40.9 minutes. And for the last example, 2 hoses fill up a swimming pool in 3 hours. If only hose A is used, the pool fills in 4 hours. How long will it take to fill the pool if only hose B were used? So in this case, I know what the time working together is. I know it's going to be 3. So I can put the time working together on the top as 3. To complete the one job. I know hose A takes 4 hours, so this is going to be 3 over 4. I don't know how long hose B takes to do it itself. So I'm going to state that let B represent the time it takes for hose B to fill the pool. By itself. Now the common denominator is going to be 4B. So I can state that 4B times 3 over 4 plus 4B times 3 over B is equal to 4B. Cancel the 4, cancel out the B. And I can state that 3b plus 12 is equal to 4b. When I move the 3b over, subtract 3b from both sides, 12 is equal to b. It takes hose B 12 hours to fill the pool. And that is it for Chapter 6.